Yesterday I asked you to try a couple on your own, and hopefully you work these out yourselves. And when you split the first one up to a over x plus 5 plus b over x minus 3, when you do your math, you solve it and you get a equals 5 and b equals -2. So that partial fraction decomposition will be 5 over x plus 5 minus 2 over x minus 3. And this is without all of the algebra shown. Hopefully you got that algebra shown in your own notebook. And then the second one I asked you to try, when you split that one up, you'd get a over x plus 1 plus b over x minus 1, or you can reverse the a and b. But you let, when you do the math, you get a equals 4 and b equals 3. So it turns out to be 4 over x plus 1 plus 3 over x minus 1. And again, this is shown, the answer is shown without all of the algebra. So today we're going to do case 2. I think we'll only have time to do case 2, and we'll do case 3 tomorrow of partial fraction decomp. So case 2. Case 2 is when the denominator consists of repeated linear factors. Repeated is the key word. Linear factors, there's no x squared in the denominator. So there's a different setup for repeated linear factors, and the form of the denominator usually when you talk about a linear factor, you can call it y equals mx plus b. So I'll just call it mx plus b. That's a linear function. And the repeated means that this linear factor in the denominator is raised up to some power n. It's repeated n times, and you'll see what I mean when we go through a couple of examples. So how you split that out into partial fraction decomp, the form is, first of all, you put the letter a over the mx plus b, whatever that is, and that gets raised to the first power. And then you put the letter b over the mx plus b raised to the second power. Usually we don't have anything above n equals 2 or n equals 3, but just in case, or just for completeness, you would have another constant c over mx plus b raised up to the third power plus dot, 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 and however many factors there are, you would go up to the letter, I don't know, I'll just call it little m. I don't know what that number is, and that would be mx plus b raised up to the nth power. So you'd have a, b, c, d, e, f, g, but you'll never get that many. So that's the form if you have the denominator repeated n different times. So what does this look like in example? Hopefully I'll get time to do 3 examples for you. The first one will be 5x squared plus 20x plus 6 all over x to the third plus 2x squared plus x. This looks a little more complicated than what we had yesterday. But what we're going to do is we're going to factor the denominator. You can see the GCF is x. So I'll just cross that out and take an x out, and you're left with x squared plus 2x plus 1. And then this is factorable into x plus 1 times x plus 1. So this denominator becomes x times x plus 1 to the second power. And that's the linear factor that's repeated 2 times. So what we're going to do in our setup is, first of all, we have the capital A over this factor. We can't forget about the x. So a goes over x. And now we have this factor repeated twice. So we'll do b over x plus 1 to the first power, like this form right here. And then we'll have the next letter in the alphabet, c over x plus 1 to the second power, and we stop right there because we only have this repeated twice. So there's the form of the partial fraction decomp. Now our next job is to proceed like we did yesterday. We multiply both sides of this equation by the LCD. Well, this is the LCD right here. So that gets canceled out, and you're left with the numerator that I gave you, 5x squared plus 20x plus 6. And if we multiply this times that LCD, this x will cancel with that x, and we're going to be left with a times x plus 1 to the second power. And if we multiply this fraction by the LCD, we're going to be left with the x and one of those x plus 1s. So the b stays. This x is this x. And then one of these two x plus 1s will cancel, so we're left with x plus 1 to the first. And the c gets multiplied by the LCD. Well, this whole x plus 1 squared cancels out with this x plus 1 squared, so you're left with cx. And now we have an equation kind of like what we had yesterday. And if we look through this, if we let x equal -1, then those two terms will go away. So if we let x equal -1 over on the left, we get positive 5, because -1 squared is 1. So 5 minus 20 plus 6 is equal to 0 plus 0 plus -c. When you add these together, you get -9 equals -c, so that means c equals 9. You can do the math if you want. The next convenient number to let x equal is 0. If we let x equal 0, then this term goes to 0 and this term goes to 0, so we'll be able to solve for a. So we're going to let x equal 0 this time, and when we plug in 0 on the left-hand side, we get 6 is equal to a, because 1 squared is 1, so 1 times a, plus 0 plus 0. So that was easy. We get a equals 6. And now we've kind of run out of numbers to use, so we can let x equal anything we want, anything that's easy. I usually try to let x equal 1 because usually that's pretty easy math, but you can let it equal anything you want. So let x equal 1 just for the heck of it. And over on the left-hand side, we get 5 plus 20 plus 6 equals, now we already know a is 6, so we're going to substitute 6 in for that a, and x equals 1, so 1 plus 1 is 2, 2 squared is 4. B we don't know, so we have b times 1 times 1 plus 1, which is 2. So we substituted 1 in for those two x's, so we really have a 2b here. And we already found out that c was equal to 9, so we're going to put a 9 in for that c. 9 times 1 is 9. So when we add these up, we get 31 on the left. 24 plus 9 is 33 plus 2b. Subtract 33 from each side, and you get -2 is equal to 2b. So we get b is -1. And so we've solved for the three constants, so now all we have to do is put it into the original form. So the partial fraction decomp is 6 over x minus 1 over x plus 1 plus 9 over x plus 1 raised to the second power. And that's the end of that problem. These take a little bit longer to do because oftentimes you have more variables to solve for, or constants to solve for. Let's do an example number 2. Let's decompose x plus 2 over x cubed minus 2x squared plus x. So we pull an x out, and we have x times x squared minus 2x plus 1. And that's factored into x minus 1 times x minus 1, which is x times x minus 1 to the second power. So when we have the setup here, we have a over x plus b over x minus 1 to the first power plus c over x minus 1 to the second power. And we stop there because that's all it's raised to is the second power. So our next step is to multiply both sides by the LCD, which gets rid of this. And on the left-hand side, we're just left with x plus 2. When we multiply this by the LCD, the x's cancel out, and you're left with a times x minus 1 squared. B gets multiplied by this x and one of these two x minus 1s, because the other one canceled out. And c gets multiplied just by x, because that x minus 1 squared canceled out with that x minus 1 squared, so you're just left with cx. All right, so now let's let x equal 1. So we have 3 is equal to 0 plus 0 plus c. Next, let x equal 0. Oh, I forgot my x here. Sorry. So when x equals 0 on the left-hand side, we have 2 is equal to a times 0 minus 1 is negative 1. Negative 1 squared is 1. So we have a, and then plus 0 plus 0. So we have a and c solved for already. And now we just have to figure out what b is. Well, let's see. We let x equal 1. Let x equal 0. What's another easy one? I think if I let x equal 2, we're going to have 2 minus 1, which is 1 squared. And I'm just going to let x equal 2. That seems easy to me. You can let it equal anything you want, but 2 seems like a good number for me on this problem. So when you let x equal 2, you get 2 plus 2, which is 4. A is already found out to be 2, so we can put 2 in here. 2 minus 1 is 1. 1 squared is 1. So this term turns into just plain old 2. We don't know what b is, so we have a b in there, and x is equal to 2. And 2 minus 1 is 1, so this term turns into that. And c we already found out to be 3, and since x is 2, 3 times 2 is 6. So we have 2 plus 6 is 8 on the right-hand side, and if you subtract 8 from each side, you get negative 4 is equal to 2b. Divide both sides by 2, and you get negative 2 equals b. So we solve for all three of those, so now all we have to do is set it up in the end. 2 over x minus 2 over x minus 1 plus 3 over x minus 1 raised to the second power. And there's our partial fraction decomp for that example number 2. Example number 3 is going to be quite a bit lengthier, more lengthy, however you want to say it, but this is going to take some room to do. So hopefully you've got some room in your notebook to conquer this problem. Here it goes. 2x to the third plus 6x squared plus 6x plus 9 over x to the fourth plus 6x to the third plus 9x squared. So there's your given problem. So our first job is to factor the denominator completely. So we see the GCF is x squared, so let's take the x squared out, and we're left with x squared plus 6x plus 9. And then we can see that this is x plus 3 times x plus 3. So when we factor this completely, we have x squared times x plus 3 squared. Now what we have is we have two repeated linear factors. This is a linear factor. It's repeated twice. This is our second repeated linear factor twice. So we're going to have a setup with an a over x to the first plus b over x to the second. That takes care of the first repeated linear factor. Now I have c over x plus 3 to the first, plus d over x plus 3 to the second. So now we have 4 variables to solve for, but it's really not much different than the other ones we've been doing. It just takes a little bit longer because we have an extra constant. So when we multiply both sides by the LCD, we're left with, on the left-hand side, 2x cubed plus 6x squared plus 6x plus 9. Now, if we multiply the first term by the LCD, one of those x's are going to cancel, so you're left with ax times x plus 3 squared. Multiply the second term by the LCD, and the x squareds go away, and you're left with b times x plus 3 squared. Multiply the third term by the LCD, and you get c times x squared times x plus 3 raised to the first power, because one of them canceled. And then the last one is, when you multiply the last term by the LCD, the x plus 3 squareds go away, so you're left with d x squared. So hopefully the first thing you saw was we should let x equal -3 to get rid of all of those terms right here. Let x equal -3. So when we let x equal -3 over on the left-hand side, we have 2 times -3 cubed, which is -27, plus 6 times -3 squared, which is 9. 6 times -3 is -18, plus 9. So here's our left. And over on the right-hand side, this goes away, this goes away, this goes away, and all we're left with is d times -3 squared, which is 9d. When you add these together, this is -54, this is +54, so they go to 0. This becomes -9 equals 9d, so we have d equals -1. Here's our first variable. The second easy thing to let x equal is 0, because that will make the first and the last two go away. So let's let x equal 0. So on the left-hand side we get 9 is equal to 9b, because all the other ones went away, went to 0. So that tells us that b is equal to +1. So there's our second one. Now we have to figure out two other numbers to let x equal. And it can really be anything. I think I'm going to let x equal -1. That makes my math a little bit on the easy side, but you can let x equal anything you want. So let's just go for -1. So when we put -1 in here, we get -2 plus 6 minus 6 plus 9 equals -a times 4. A times -1 times 2 squared. Plus, now b is already equal to 1, so 1 times 2 squared is 4. So we got 4b here. Whoops, b is equal to 1, so it's just plain old 4. Plus, we don't know what c is. C times -1 squared is 1, so that's just c. And then -1 times +3 is 2, so we've got c times 2. And then we already found d to be -1, so this is -1 times +1, which is -1. So we'll just clean up our act a little bit over here, combine all these together, and you get 7 is equal to -4a plus 2c, 4 minus 1 is 3, plus 3. All right, and if you subtract 3 from each side, you get 4 is equal to -4a plus 2c. And I'm just going to make this equation a little bit easier by dividing everything by 2. So we've got 2 is equal to -2a plus c. So we can say that C is equal to 2a plus 2 if you add 2a to both sides of this equation. So we're going to use that in a substitution with our next one. Last thing we're going to do is let x equal -2. I just pulled that out of the hat because I thought that might be an easy thing to substitute in. So when we let x equal -2 and put it into this equation right here, we get 2 times -8 plus 6 times 4, 24. 6 times -2 is -12 plus 9. That's the left-hand side of the equation. And then on the right-hand side of the equation, we already know b is 1 and d is -1. And we know c is equal to 2a plus 2, so we'll substitute that in when we do our math here. So we've got a times x is -2a times -2 plus 3 is 1, and 1 squared is 1, so that's just a 1, plus b is 1, and -2 plus 3 is 1, squared is 1, plus c, we don't know what c is, but we do know that it's 2a plus 2, so we can substitute that in, 2a plus 2 for c. X squared is 4, and -2 plus 3 is 1, and d is -1, and -1 times 4 is -4. So we have this great big long equation here that we can solve for a. So you're going to add everything on the left-hand side, everything on the right-hand side, and let's see, I don't want to lose my place here, so I think I'll just use another sheet of paper and transfer it later. So we have -16 plus 24 minus 12 plus 9, which looks like it's equal to 5. 5 is equal to -2a. Let's see, 1 and -4 is -3, so I'll get rid of those. 2a times 4 is 8a, and 2 times 4 is 8. So it looks like we have -2a plus 8a, which is 6a, and -3 plus 5 is 5, or plus 8 is 5. So if you subtract 5 from each side, you get 0 equals 6a. So a is equal to 0. So now we know a, b, and d. And now we can just solve for c because we know from up above that c is equal to 2a plus 2. A is 0, so c is equal to 2. So those are our four values, 0, 2, 1, and -1. And now all we have to do is substitute it in to the original partial fraction breakdown. And our final answer is 0 over x, which I'm not going to put down. B is 1. So 1 over x squared. Let's see, you can't see that. Here you go. So 1 over x squared, because b is 1. C is 2, plus 2 over x plus 3, and d is -1, so -1 over x plus 3 raised to the second power. So there is the partial fraction breakdown for that original problem. And hopefully you can see everything that I wrote. And that's it for today.